Hello friends, this is the last video of the scheduling policies video series, and in this video I'm going to discuss round robin algorithm. So in the previous videos we discussed first come first serve, shortest job first and priority scheduling. So this is the last video and let's start. So here you can see that there are two new words that I have written. Right, so one is request queue and here there are two letters TQ. So here TQ means time quantum. Time quantum. Right, so now I will tell the meanings of these two words. Time quantum means this TQ determines the amount of time that the process will be executed. Right, so you can note it down. Time quantum determines the amount of time that the process will be executed. So in here also, as same as in the first come first serve, we ignore the burst time, right? Regardless of the burst time, even though the burst time is large or small, we have to ignore that. Regardless of the burst time, the process has to execute for that given particular amount of the time quantum, right? So I'll repeat it again. Regardless of the burst time, I'll write it down. Regardless of the burst time, the process has to execute for that particular amount of time. Right, so here also we ignore the burst time. And now the request queue. So what is this request queue? When the processes are arriving, right, when the processes are arriving, we have to put these processes into the request queue according to their arrival time, right? So what happens here in the request queue? When the processes are arriving, we have to put those processes into the request queue according to the order of their arrival time, right? Right, so those are the basic things that I wanted to tell you, and now let's start by drawing the Gantt chart. Before moving to that, in this example I am taking the time quantum as 3, right? That means the maximum amount of time these processes get to execute is only 3 milliseconds, right? That means they cannot exceed this 3. The maximum time amount is 3 milliseconds. Actually, I want to tell you this also. If you think that if you have a mindset that this round robin is difficult or it is harder than the other algorithms, actually you are wrong, right? If you get the pattern, it is nothing with this round robin. So pay your attention and see how I solve this. At the end you will understand that round robin is really easy. Right, so let's start with the Gantt chart. So here you can see that P1, it is arrival time is 0, right? That means P1 comes to the queue first. So that means P1, you have to write P1 here. So we have to start with P1. we can write P1 here. So as usual, we write 0 here. And now you can see that P1's burst time is 4, right? So in the previous algorithms, we wrote 4 here without any doubts. But here I told you that we take the time quantum as 3, right? That means the maximum time the processors get is 3 milliseconds. So even though the burst time is 4, we cannot write 4 here, right? We only can take 3 milliseconds. So we write 3 here, and you can see 1 millisecond is left, right? The burst time is 4, but you write only 3. We get only 3. So there's 1 left, right? So keep that in mind, and let's move to the next part. And we are using that in a few seconds. So within these 3 milliseconds, you can see that P2 and P3 arrives, right? Both these P2 and P3 arrives. So the P2 is the one which comes first and then the P3. So we have to write these P2 and P3 in this request queue, right? So at the beginning I told you that we write the processes. We have to put these processes into the request queue according to their arrival time, right? So we write P2 here, and we write P2 here and then P3, right? And I told you that P1 has 1 millisecond remaining, right? So because of that, after placing these 2 processes here, we are going to place P1 again, right? Because we have 1 left here. So we write P1 here. And now you can see this first P1, we wrote it in the queue. So we are going to cut it because we are done with P1, right? Now you can see the next process is P2 in the request queue, right? So we are getting from the request queue to this Gantt chart. So now it is P2 and we are going to write P2 here, right? So after placing it here, you can cut it off, right? Then let's go to P2's burst time. It is 5, but we cannot write 5 here, right? We have to take only 3. We can take only 3. So from 5, we are going to write only 3. That means 3 plus 3, 6. So how many left? Yes, 2 left, right? And within these 6 seconds, you can see P4 arrives, right? So we cannot place P4 here because there are more processes in the request queue. So we are going to place this P4 here. And then we are gonna place this P2 because P2 it has 2 milliseconds left, right? So we are gonna place P2 here. And now let's see, the next process is P3, right? And P3, its burst time is 6. So we cannot write 6. We are gonna place only 3. So 6 plus 3, it is 9 and 3 left. So within these 9 seconds, the remaining processes P5 and P6 also arrives. So we write P5 and then P6, right? And here then we place the P3 because it has 3 seconds left. P3, right? So we are done with all the processes, and now after P3, P1, we place P1 here, and P1 you can see it is only 1 second left. So without any doubt we can add this one here, right? And we are done with P1 now. P1, it is not in the queue anymore. So we are completely done with P1. And then P4. So we can write P4 here. Let's go to P4. It is 2. So the maximum number is 3. So we can place 2 without any doubt. So it is 12. Right? And we are done with P4 as well. We wrote it here. And then P2. Right? P2. P2 what happens? It is 2 and 2 is lesser than 3. So we can directly write it here. 12 plus 2, 14. Right? So we are done with P2 as well. Right? I think you got the pattern. So let's move to the next process. It is P5. So we are going to place P5 here. Right? And P5 it is 4. Right? So again we have to get only 3. So 1 is left. So 14 plus 3, 17. Right? So P5 we have 1 left. So we are going to place P5 here again. Right? And then we come to P6. P6. We write P6 here. Here also the burst time is 3. So without any doubt we can place P6 here. The complete burst time it is 20. Right. So we are done with P6 as well. Right. And then P3. We write P3 here. It is 3. So we can write the whole amount. We can write the full amount 23. Right. So we are done with P3 as well. And 6 also. And the final process is P5. So we write P5 here. It is only 1. So we are going to place it here 24. Right? Done with P5 as well. So we have placed all the processes into the Gantt chart. So we are done with that. Now let's check whether our Gantt chart is correct. So here you can see it is 24. And let's get the total of the burst time. 24. Right? So now you can see it is 24 and here also 24. These numbers are same. That means our Gantt chart is correct. So we are done with the first step. So let's move to waiting time and turnaround time. Right, let's start with waiting time. So as same as in the previous sessions, to get the waiting time, you need to keep that equation in mind. Visiting time minus arrival time. Right. We apply the same equation but in a bit different way. Right. So let's start with P1. Here you can see P1 is there 2 times, right? So that means we have to calculate the both waiting times of these 2 P1, right? So first let's see the waiting time of this first P1. So the visiting time it is 0 minus arrival time is 0, right? Now we have to add this second P1 also, P1's waiting time. So to get that you have to do this. You have to write the visiting time of this P1, right? It is 9. 9 minus, then you have to go to the first P1, right? First P1 and its right value, right side value. So it is 3 here. So you have to write 9 minus 3. Right. So now let's get the total answer. It is 6. I think you understood that. And then let's go to P2. P2, let's see the first part. So it is 3, right? 3 minus P2's visiting time is 3. So 3 minus arrival time is 2. So 3 minus 2 plus. So here this second P2 it is here, and now let's write the visiting time of this P2. It is 12. So 12 minus the first P2's right value, right? So it is 6. So 12 minus 6, and the total value here is 7. And now P3. So here in P3 the visiting time is 6 minus waiting time is 3 plus, here's the second P3. So we write 20 the visiting time and 20 minus the right value of first P3. So it is 9. So here the total is 14, right? Then let's move to P4. P4, the first P4 is here, and you can see that there is only one P4, right? So it is easy. The answer is 10 minus the arrival time. It is 4. So it becomes 6. And then P5. P5 there are 2. So the first one 14 minus 7, right? 14 minus 7 plus the second P5, it is here. So we have to write 23 minus first P5's right value, 17. So the answer becomes 13. And finally the P6, only one P6 here. So the answer is 17 minus the arrival time 8. So here it is 9. Right. So we got the waiting times of each and every process. Now let's get the total. So the total becomes 55 milliseconds. Right. And then we have to calculate the average waiting time by dividing this by 6. So because there are 6 processes, so the answer is 9.16 milliseconds. So we are done with the waiting time and average waiting time, and now we have to find the turnaround time. Right, so for turnaround time also, you know the equation now. It is waiting time plus the burst time. So when finding the turnaround time, it's not like the waiting time as the previous videos. You just have to add these two. Right, so let's start with P1. P1 it is 6 plus burst time 4. Right, so when writing the burst time, you don't need to write those second values. We have to write the original value given in the question, right? So the answer here is 10, and then P2 it is 7 and burst time 5. So the answer is 12, and then P3 14 plus 6, which is 20, and then P4 6 plus 2 8, then P5 13 plus 4 17, and finally P6 9 plus 3. Right, so it is 12, and let's get the total turnaround time, which is 79 milliseconds. And then let's get the average turnaround time. Divide this 79 by 6, 13.13 milliseconds, right? So we are done with the all 4 steps. We have the Gantt chart, then we calculate the waiting time, average waiting time, turnaround time, and finally the average turnaround time. So this is how we do the round robin algorithm, and this is the last algorithm. So in the previous videos we did the others. The links for those videos, they are given in the description. So I hope you understood the pattern, how to get these things. If you get the pattern, it is really easy to solve this round robin algorithm. So we'll meet with a new series. Till then, be safe and thank you.